To recap where we are, we've got the equation y equals 6 squared of x plus 7, and we're analyzing the expression f of x plus h minus f of x over h, which we've determined is equal to 6 times the square root of x plus h minus the square root of x over h, and we've got a graph of this function. So the graph of y equals 6 squared of x plus 7, x, not 7, here's the graph. Okay? Now, let's just take an arbitrary x and see what all this might mean. So let's just say that x is here, and h be represented by this distance, h in this case being a positive displacement this far. Looks like h is a little less than 1 here. Now, when we apply this definition in a calculus class, or to a rate of change, to an instantaneous rate of change, we're going to use a much smaller h, but I'm not going to be able to draw the picture that I need to draw if I use a tiny value of h. So, okay, now we get a point on the graph for x, and we get a point on the graph for this point, which has coordinate x plus h, and this little arrow here represents displacement equal to that of h. So up here now we have a right triangle for which we can calculate the slope. Now let's label a couple of other things. Let's label the y coordinates, okay? We're evaluating this function at x, so what we get is f of x. So here is f of x on the y-axis, and here we're evaluating the function x plus h, so here is f of x plus h. So if we enlarge this triangle, so let's bring that triangle out here and enlarge it. Okay, we can say that this point is the point x, f of x. This point is the point x plus h, f of x plus h. So you should stop the video and work this out yourself. What's the run? What's the rise? What is therefore the slope of this triangle? You should write that out. And if you end up writing it out correctly, and you're going to see in just a second of video here, whether you did it correctly or not, if you actually do this, rather than watching me do it, you know, be active. Don't sit there passively, like you're watching a television screen or something. So the x, well, if you write out the run and the rise and the slope, you're going to have something of a revelation here. Okay, so I hope you've paused because I'm going to go on. Okay, the run is from x to x plus h. So the run is x plus h minus x. And of course, that's just h. And if you go back to this picture, h is this displacement, which is the same as this run. So there's no surprise, if you think about it, that if you subtract this coordinate from this coordinate, you do get h. What's the rise? Again, if you don't have it, stop and do it before I do. You'll learn a lot more, even if you make a mistake. Okay, the rise is what? It's f of x plus h minus f of x. Why? Because that's the y-coordinate here, and this is the y-coordinate here. We did the run from this point to this point, subtracting the x-coordinate here from the x-coordinate here. We'll do the rise the same way. We take the y-coordinate here and subtract it from the y-coordinate here. Now, if you haven't already done it, stop and write out what the expression would be for the slope. I think you're going to be able to get it. Okay, so the slope is rise over run And what's that equal to? That's equal to f of x plus h minus f of x over h. This divided by this. In other words, just the expression that we're trying to evaluate. So this simplified expression tells you what the slope of this line segment is. So if we draw the line segment, which is fairly close to the curve humps up a little higher than the line segment, but the slope of the segment, and I mean by that line segment, is f of x plus h minus f of x divided by h. And that's the slope of this segment right here. Now that's a very important insight. Again, if you're on a track that requires you to take at least some sort of an applied calculus course, if not full-blown engineering calculus. And that's a very important property of the function. It's the slope of the function. It's the change in the y value divided by the change in the x value. So there's another interpretation. F of x plus h minus f of x over h is change in the y value divided by the change in the x value, because the rise here is the change in the y value, so there's the change in the y value. The run is the change in the x value, and that's h, so we have rise divided by run, change in y divided by change in x, and this is the average rate of change, ROC standing for rate of change, of y with respect to WRT with respect to x on the interval from x plus to x, from x to x plus h. Now, in calculus, just to give you a little preliminary, because it's kind of a neat idea, all we do is we think of shrinking h to 0, and when we do, we get an expression for the slope of a graph right at this point x. And that's a very profound thing. You don't need to worry too much about that right now, but that's the reason why we talk about this difference quotient in this course. It's very important, very central to the idea of calculus. It's right at the heart of calculus. And when and if you get into a calculus course, it's going to be much, much to your advantage that you understand how to handle these difference quotients. We're not going to talk about taking limits at this point. We're just going to stick with the analysis of the difference quotient. There's one more thing I want to do with that difference quotient, so we'll continue in a second.